Fourth question is, a block of mass m is connected to another block of mass capital M by a massless spring of spring constant K. The blocks are kept on a smooth horizontal plane, that means friction is zero. Initially blocks are at rest and the spring is unstressed. Then a constant force F is started to act on the block of mass capital M to pull it. Find the force on the block of mass small m. As per the question, if we make a diagram, this is the block M which is connected with a spring to a block of mass capital M. As per question, the spring constant of the spring is K and a constant force F act on the block M. Then if we make a free body diagram of the small m and capital M, then F is acting on the capital M and there is a restoring force F1 on the spring which act on the mass capital M. Similarly, this F1 acts on small m, because if we make a diagram, the force act in this way. So the force acting on the mass m is given by this. This is the force acting on the spring and this is the force acting on the block capital M. This is the F1. Here is also F1. This is F1 and this is also F1. So we can write, if the system is moving with an acceleration A, then we can write F minus F1 equal to ma. Similarly, F1 equal to small ma. On adding, we will have F equal to capital M plus small m into A. Therefore, acceleration will be equal to F by capital M plus small m. This is the acceleration of the system. So, force F1 which act on the small mass m, it will be m into A. This is equal to m into F by capital M plus m. Hence, the option C is the correct option. Fifth question is, a block B is pushed momentarily along a horizontal surface with an initial velocity v. If mu is the coefficient of sliding friction between the block B and the surface, then block B will come to rest after a time. On a surface which has friction, the retarding force will be equal to mu mg and retardation will be equal to mu g. This we have to remember for a horizontal surface. And this can easily be calculated as, this is the block which has mass m, so weight due to gravity act downward, and because of this weight, block will experience a normal reaction force and n will be equal to mg. And the push is given on the right hand side, so there will be a friction force F in the opposite, and this friction force will be equal to mu n, and it is mu into mg from the first equation. So friction force is mu mg, which we have written here. This is the retarding force, and this friction force act on the block B which has mass m. So we can write this is m into a equal to mu mg. Therefore, acceleration, or we can say retardation, due to the friction will be equal to mu g. So for horizontal surface which has frictional coefficient or coefficient of friction is mu, the retarding force will be mu mg and retardation will be mu g. Now as per the question, the push given to the block B gives the initial velocity, that is u equal to capital V, and final velocity will be 0 when it comes to rest, and retardation is equal to minus mu g. So using the equation of motion to find the time, we will use first equation of motion, v equal to u plus at. Substituting the value, v equal to 0, u equal to capital V, plus a is minus mu g into t. Therefore, t equal to v by mu g. Hence, option D is the correct option. Next question is, a plank with a box on its one end is gradually raised about the other end As the angle of inclination with the horizontal reaches 30 degree, box start to slip. That means in this situation, the frictional force, which is the static friction force, becomes maximum static friction force, and that will be equal to mu into normal reaction force. And it slides to 4.0 meter down the plank in 4.0 second. Find the coefficient of static friction and kinetic friction between the block and the plank. So in the limiting condition, when the block is just to slide down the inclined plane, then the friction force will act in upward direction, and component mg along the plane will be mg sin theta, and mg sin theta, which is acting downward, get balanced by the maximum static friction force. This is equal to mu n, and it is equal to, because mg cos theta is the component perpendicular to the inclined plane, which is balanced by the normal reaction on the block due to the plane. So it is mu into mg cos theta. So computing these two, we will have mu equal to tan theta. And the angle for which this balancing take place is 30 degree. So this implies that mu equal to tan 30 degree. It is equal to 1 by root 3, and it is approximately equal to 0.6. So this is the coefficient of static friction force, and its value is 0.6. To calculate the coefficient of kinetic friction, the downward force is mg sin theta minus upward force on the plane is mu, which is the kinetic friction when body slides, into mg cos theta, and that is equal to m into a mass and acceleration in the block. So acceleration in the block will be g sin theta minus mu k g cos theta, and it is given that the body or the block slides 4.0 meter in time equal to 4.0 second, and initially body was at rest, so u equal to 0. So using the second equation of motion, that is s equal to ut plus half at square, this implies that 4 is equal to 0 plus half into a into t square, that is 4 square, and this will give 4 equal to 8a. That means 0.5 is equal to a, and a is equal to g sin theta minus mu k g cos theta. Substituting the value of theta equal to 30 degree, so it is g sin 30 degree minus mu k g cos 30 degree. So substituting value 0.5 will be equal to, g is 10 and sin 30 is 1 by 2, so it is 10 into 1 by 2 minus mu k into 10 into root 3 by 2. So it is 0.5 equal to 5 minus mu k into 5 root 3. So mu k equal to 4.5 by 5 root 3. That is equal to, on simplifying we will get it is 0.5. So option D is the correct option. Next question is, a horizontal force of 10 Newton as shown in figure is necessary to just hold the block stationary against a wall. The coefficient of friction between the wall and the block is 0.2. The weight of the block is, if we make the free body diagram of the block, then its weight is acting downward, which we have to calculate. A horizontal force is acting on the block, which is 10 Newton, and this press the wall, and wall give a reaction force R, that will also equal to 10 Newton, because there is no motion in the horizontal direction, and block is in contact with the wall, so there is a friction force F. Now block is at equilibrium, That means there is no motion, so we can write that work is equal to friction and R is equal to 10 Newton. And this friction will be equal to mu into R, that is equal to mu into 10. And mu is given 0.2, so we will write it as 0.2 into 10. Hence weight of the body will be 2 Newton. Hence option D is the correct option.